Yes, welcome back from TRIS. The topic is organic chemistry. The subtopic is chemical properties of alkanes. So we are still dealing with the substitution reactions of alkanes. And last time we dealt with the substitution reactions involving methane and chlorine, excess chlorine. We said that if you have methane plus excess chlorine, then in the presence of UV light, then all the four hydrogens are substituted. All the four hydrogens are substituted, and the other product is hydrogen chloride. So when we balance this, we have four hydrogen. We need to have four hydrogen there. Then four chlorine. So this one involves complete substitution by using excess hydrogen, where what will be formed will be tetrachloromethane. Tetrachloromethane. And tetrachloromethane is a liquid. It's a liquid substance. It's a colorless liquid. But today, we want to look at the substitution reactions of methane, but now we are going to use limited chlorine, a small amount of chlorine. We will be using limited chlorine. Now, in limited chlorine, so when we talk of limited chlorine, only one hydrogen will be replaced or will be substituted by chlorine. So here we talk of limited. Or sometimes they will tell you, write an equation for the reaction between methane and 1 mole of chlorine, meaning a small amount. We still need UV light. So only one hydrogen will be substituted, so that we'll have CH3Cl plus hydrogen chloride. So in this case, we will have a gas, methane, gas. This one is chloromethane. In terms of open structure, we'll have one carbon, then chlorine. So the light energy will break the chlorine bond, then one chlorine will come there. So we'll have plus hydrogen chlorine. So these are gas. So this one is in terms of open structure. So whenever we are using 1 mole of the halogen, or limited, meaning small amount, only one hydrogen will be substituted. The rest will remain. So that is how the reaction occurs. That is how the reaction takes place. Now the second example, which we are going to do, we are going to see how ethane reacts with bromine. So we'll talk of ethane plus excess bromine. So bromine and excess. So in this case, what will happen is that all the carbon atoms, not the carbon atoms but hydrogen atoms, will be substituted, so that in the first step, in step 1, let me put it in form of steps. So reaction, let's have it as number 2, reaction of ethane with excess bromine. The reaction of ethane with excess. So step 1. In step 1, the ethane, which is C2H6, will react with bromine, and we need UV light. This one is in excess. So the first step, one hydrogen will be replaced. So we'll have C2H5Br plus HBr. One bromine will move here to replace hydrogen. And then, so you will have 5 hydrogen. Then the hydrogen which has been replaced will combine with bromine to form hydrogen bromide. So this one is bromoethane. Bromoethane. Now, in terms of structure, if we have ethane, this one is ethane plus bromine in the presence of UV light. One bromine, the bromine will break up, bromine bond, break it up. One bromine will come here, so that we will have this one remaining intact. Now bromine will come and replace, substitute hydrogen. Then that bromine, this hydrogen will combine with the second bromine to give hydrogen bromide. So this one is in terms of the open structure. Now, in the second step, it is this one that will now get substituted. So in step 2 now, that is step 2, this bromoethane C2H5Br will react with more bromine. And remember, we still have excess. So this one still have excess. So again, in the presence of UV light, one bromine will come and replace one hydrogen. So instead of having 5 hydrogen, we remain with 4. And then Br2 plus hydrogen bromide plus hydrogen bromide. So now we have 3 bromine, 5 hydrogen, that is 5 hydrogen. So it is balanced. So this one is what we have. That is what we have. But in terms of open structure, we have bromoethane, that is bromoethane, plus bromine molecule, So again, this will break. Let us take this bromine here. So we'll have bromine, carbon, bromine, hydrogen. So one bromine will come and substitute this hydrogen so that we have our bromine. This hydrogen will move to the remaining bromine so that we get hydrogen bromide. So these are 3 bromine atoms. We have 3 bromine atoms. Hydrogens are 5. So this one, you can name this as, there is bromine at carbon 1 and bromine at carbon 2. This is carbon 1, this is carbon 2. So you call it 1, 2, dibromoethane. 1, 2, dibromoethane. So because we still have more bromine and we still have hydrogen to be replaced, in our second segment we are going to move to step 3. So let us meet again in the second part to continue with step 3.